Hello guys, welcome to Ausbildung. So today we will solve one numerical that will be based on a current profile or a current time profile of a signal. So let's begin with today's session. This question says here, a current IT has been shown in a figure. If it is applied across a pure inductor of 20 millihenry, find the profile of VT. So we have to apply this graph across the inductor. So we know that voltage across inductor is given as LdI by dt. First of all, let us see the slopes of various regions. So for region A, slope will be equal to 0 because here we can see no slope is there. For region B, slope is equals to 20 minus 10, that is y2 minus y1 upon x2 minus x1. x2 is 1 minus x1 is 0. So here we will get 10 ampere per second because it is di by dt. Next is for region C, we are having slope is equals to y2 is minus 10 minus 20 upon 3 minus 1. So that is equals to minus 30 by 2, or that is equals to minus 15 ampere per second. So for region D, slope is equals to, we can see here for region D, y is 0 minus 10 upon 5 minus 3. So here we will get 0 minus times of minus 10 upon 5 minus 3. So that is equals to 10 by 2, or we can say here 5 ampere per second. Okay, so now for period A, voltage across inductor is equals to L into di by dt. That is equals to L is given as 20 milli and di by dt for region A was 0. So that is equals to 0 volt. And for period B, voltage across inductor is equals to L into di by dt. That is equals to 20 milli into di by dt for period B was 10. So here we will have 20 into 10, that is 200 into 10 is per minus 3. It is equals to 0.2 volt. In similar manner, we will calculate for period C. So voltage across inductor is equals to L into di by dt. So that is equals to 20 into 10 raised to the power minus 3 into di by dt for region 3 is minus 15. So that will give us minus 0.3 volt. And for period D, voltage across inductor is equals to L into di by dt. So that is equals to 20 into 10 raised to the power minus 3 into 5. So that will give us 0.1 volt. So let's draw the graph for obtained signal of voltage. So here this axis will be written as Vt, volt, and here this axis is in millisecond time. So we have obtained the graph in this manner. Step signal, because differentiation of graph will give us step. So here we are having this signal. This is 0.2. Here we are having 0.1, and here we are having minus 0.3 volt. So in this way we will draw the graph of this signal of voltage. Guys, hope you all understood the question. So if you all have not gone through previous videos, please go through that. I will share the link in the description box. Please like, share and subscribe and press the bell icon. Bye guys, meet in the next session.